All right, welcome back. Today we are going to be taking a look at the distributive property. So the distributive property is when you have a factor and it is multiplied by the sum, which remember means addition, or difference, which is subtraction of two different terms. You might use this, and I often use this for things like mental math. So for example, if I was taking 7 times 23, I don't know what 7 times 23 is off the top of my head, but what I can do is I can take 23 and break it into parts that I know how to multiply by 7. So I might break my 23 into 20 plus 3, and 7 times 20 plus 7 times 3. And now I can think of this as two separate parts. So 7 times 20 is 140, and 7 times 3 is 21. So now I know that 7 times 23 has an answer of 161. All right, so thinking about that, I want you to try the next one on your own. So go ahead and pause the video and try this one on your own. Now you can break up 57 lots of different ways. I typically just break it into 50 plus 7, which means then I'm taking 4 times 50 plus 4 times 7. 4 times 50 is 200, and 4 times 7 is 28. So 4 times 57 is 228. Where we are now in math, though, we are not always going to be using a number times another number. We might be taking a number times a variable or groups of things. So if you remember here, what we're looking at is we have 3 groups of x plus 9. So we could think about that is we have kind of stacked on top of each other these 3 groups of x plus 9. So altogether, we have 3 x's and we have 3 9's, which is 27. So another way we can look at it is what we're doing is we're taking what's outside the parentheses and we're distributing it to each part inside the parentheses to make those groups. So we have 5 groups of x minus 3. So I have 5 groups of x, which is 5x, and I have 5 groups of 3, which is 15. And because there's this minus sign here this time, this becomes 5x minus 15. All right, now we have 4 groups of 2x. So I have 4 groups of 2x's, so that would make 8 x's. And then we have 4 groups of 9, which is 36. And since there's a plus sign, I'm going to put a plus sign in between. Why don't you pause the video and see if you can try this next one on your own. All right, so here we have 6 groups of 3a. So 6 groups of 3 makes it 18 a's. And then we have 6 groups of 1, which is 6 times 1 or 6. And since there's a minus sign, this becomes minus 6. If you remember from earlier in the year, we worked on things like greatest common factor. And we can actually factor these polynomials that we're making as well, or these expressions. And what we're going to do is we're going to find the greatest common factor of the terms, and we're going to divide each term by the GCF and leave the remaining parts in the parentheses. Hopefully you remember kind of that cake strategy that we use, because that's probably one of the easiest ways to do this. So what I'm going to do is I'm going to have 7x plus 14, and I'm just going to look at the numbers at this point, and I'm going to ask myself, what can 7 and 14 both be divided by? In this case, they can both be divided by 7. So 7 divided by 7 is 1x, but we can just write that as x, and 14 divided by 7 is 2. I'm going to bring down that plus sign. Is there anything that x and 2 can both be divided by? Well, since x does not have a number in front of it, we're going to say that their common factor is just 1. Now what I'm going to do is I'm going to multiply these parts to get that greatest common factor. So 7 times 1 is 7. That's going to be the number outside my parentheses. And then here's the nice thing about doing it this way is this part that's left over becomes what's in our parentheses. So here it becomes x plus 2, and that is our factored form of 7x plus 14. And if you wanted to check, you could go back and redistribute. So 7 times x is 7x, 7 times 2 is 14. All right, let's try another one. What is something that 2p and 9 can both be divided by? So what could 2 and 9 both be divided by? Well, since 2 can only be divided by 1 and 2 can't go into 9, their greatest common factor is 1. And whenever this happens and their greatest common factor is 1, we call these prime, okay, which means we cannot factor. All right, if you want, why don't you pause this last one and see if you can try this one on your own. All right, 10y and 45, those could both be divided by 5. So 10 divided by 5 is 2. 45 divided by 5 is 9. All right, and now we kind of have a situation like we did in the last one. We have 2 and 9. They can both only be divided by 1. So 5 times 1 is 5. And then inside of parentheses is 2y plus 9, and that is our factored form of 10y plus 45.